to RLC MATLAB Academy. Today we are going to discuss about how to fix PV array sizing. This is the initial step for PV array or PV system modeling. We are going to discuss about PV array sizing. Now we are going to discuss what are the components are used in this PV array sizing. For that I am going to first select this is the PV array. Next, the input of PV array is first one irradiance and second one temperature. For irradiance I have selected two. First one is constant irradiation, second one is variable irradiance. Next one temperature I have selected 25. Next, output of PV array is DC supply, this is plus, next one minus, and the power, this is the power, output power. We will check inside the rating calculation. Next, the PV power will given to the bus selector. This is the bus selector, and directly I have connected with the scope for what we get the voltage, current and power. Product of these two will get the power. Next, the DC supply is given to the load side. This is the load. Next, I have to take the voltage measurement and current measurement in series and voltage measurement in parallel. I have to check the load side voltage, load side current and product of these two. This is the load power. We need to know first the PV rating. For that, first of all we need to know the our load side demand. For example, you are using one laptop, one TV, fan, AC. For that, how much loads you are daily consuming. For that only we have to fix the PV array if you are need to buy. For that, for example, we need 2000 or 100 watts you are using daily, or 200 watts or 500 watts. That is the your goal to decide PV rating. I am going to select the PV panel. This is the PV panel. This is the rating inside the PV panel. You can check. These are the details. I didn't change anything. This also I didn't change anything. I have selected the default setting user defined. Then I have only changed these two details. What are the details? Parallel string and series string. 3 and 4 in the details. So now I am going to calculate the PV rating. For that I am going to multiply 3 into 4. 3 into 4, that is 12. I am going to multiply this 12 with maximum power. So 12 into 213.15. You have to multiply 12 into 213.15. The result, this is series connected string, this is parallel connected string. These are the number of panels you have to add. Multiple panels you are installed for this power rating. This will come around 2500 and something, around 2.5 kilowatt. This is the power rating. You can check the power rating from the characteristics plot. Now you can select the plot and you can see here 2557. 2557. This is the from y-axis. Y-axis the power will be mentioned 2557 watts. The maximum power you will get. Okay, this is the power rating. I have selected for 25 degrees Celsius and quick plot. Now you can check the one module. One module means if you can receive the power 213.15. Like that you will get one module rating. I have plotted. You can check. This is the power rating. You will get 213.15. This is the rating given in the maximum power, and you have obtained the characteristics. This one only. This is the power characteristics, IV and PV characteristics of the PV panel. Now you have to change according to your power requirements. You can increase. For example, I am going to give parallel string is 5, series string is 5. Now you can multiply 5 into 5, 25, and multiply with 213.15. Now I am going to give apply. Then I am going to check at 25 degrees Celsius. I will check the total power for this series and parallel connected strings. This is the series and parallel connected strings after changes. This is 5328 watts. That is 5 kilowatt panel. Around 5 kilowatt panel we have designed. So like that you have to change your series and parallel string data according to your requirements, and nothing other details you can change. So you can directly use this as. Now I am going to close this. This is the variable irradiance data 0 to 0.2, 0.4, 0.6, 0.81. Based on that, the irradiance level 1000, 600, 400, 200 I have selected. For that we will get the result. For irradiance level is decreasing, the power also will decrease. This is the constant irradiation. You can select the manual switch to change your details. So this is the constant block. You can select the constant block and enter the details. This is the star generator. This is the PV panel. You can select go to block to write this one, or else you can delete it. This is the bus selector. You can use the bus selector. Double click everything. You can double click the screen and type whatever you need. Bus selector. You can select the bus selector and connect it directly. Okay. I have connected directly, and inside that you can select the bus selector like that and click it. For example, you can connect this here. We will get the details VPV and IPV. Without connecting this one, we will not see the details. Select VPV and IPV. For example, select VPV, select IPV, then remove this details. Next, you can give apply, and then you have to get the two output. Like that you can select the bus selector. Now I am going to directly give into the scope. This scope I am going to type scope here. The scope, double click the scope and press the settings. The number of inputs I am going to see. The number of input is one is voltage, power, current, then power. I need 3 inputs. Layout, I need 3 different graphs. Like that I will change it according to this one. This is the product block. You can type product and you will get it. Likewise, you have to add the current measurement and loads, voltage measurement. Double click the resistance value I have mentioned. Light load, that is 4 ohm resistance. You have to connect the scope with load voltage, load current, then product of these two, that is load power. First we need to check the constant irradiation. Double click the manual switch and get the status like this. So now you can run the MATLAB. Before that you have to select the power GI block. In that I have selected discrete and 1 e power minus 4. Based on that you have to select the model setting also. In this you have to click and fix it step and put the solver details. Same 1 e power minus 4 you have to mention here. Then click apply, then OK. These are the settings mentioned in the system. So now I am going to run the system. I have run. First I am going to check the PV power. This is the PV power rating. Next, this is these power settings I have mentioned for the PV array sizing is 3 and 4. I have changed the rating 3 and 4. For that I have changed 3 and 4. My output target is 2557 is my PV rating. For that, I am going to run the simulation. I am going to check the scope details. This is the PV power for constant irradiation. Our PV panel rating is 2557. I am getting 2100 and plus. Next, I am going to check the load size. Click the scaling theme. I will get the scope 1 and scope 2 results. In this, I need to get the standard output for this settings. I need, this is single panel rating. For this, I will get 2557. For that, this is the PV panel rating for 2557. I am not getting the exact result due to the MPPT techniques. What is the main reason for MPPT techniques? Maximum power point tracking. For that only, we need to connect with this and get the maximum power from the PV panel. Now I am going to connect the staircase generator for varying irradiance. Now I am going to run the simulation. This is the variable irradiance level. For starting, it will achieve 2000 plus. For example, our maximum power will be 1557. It will get around 2000 plus. Next, the load side, we need to scale again. Same, we will get this also. For that only, we need to extract the maximum power from the PV panel. Means we need to include the MPPT. What are the MPPT techniques are available in the PV system? Means one is PNO MPPT, incremental conductance MPPT, ANN MPPT, fuzzy MPPT, and ANSYS MPPT. There are more MPPT techniques are available. Next class, we will discuss one by one. Thank you for watching our videos. Kindly subscribe our channel for getting more MATLAB models technique. Thank you.